Let us see a numerical to find out how it becomes significant when we have a volume change during any reaction or a process to find out the enthalpy or internal energy change of a reaction. The numerical is calculate delta U, it means the internal energy change when 1 mole of water is vaporized at 1 bar and 1 bar pressure and 100 degrees Celsius. Molar enthalpy change for vaporization of water at 1 bar and 100 degrees Celsius is 41 kilojoule per mole. So that means what? The enthalpy change for this reaction when 1 mole of water liquid is converted into 1 mole of water vapors at 373 Kelvin and 1 bar pressure, it has been given that the enthalpy change of this reaction is 41 kilojoules per mole. Now we know the equation that it is delta H naught is equal to delta U plus delta NGRT. Now this is 41. We have to find out delta U. We can find out delta Ng. The gaseous is only 1. Product is 1 minus 0. It is 1. So it is 1. Into R, we all know it's 8.3 joules per Kelvin per mole. And temperature is 373 Kelvin. So it is 8.3 into 373. This delta U becomes 41 minus, it is 3.096 kilojoules. This is in kilojoules, this is in kilojoules. Remember. So this is in kilojoules. So when we subtract this, what we get is 37.904 kilojoule per mole. So this much is the internal energy change when 1 mole of the liquid water is converted into vapors at 373 Kelvin.